Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is June 2018, paper 2, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Okay, question 1. Here is a circle. Circle the word that describes the shaded part. Okay, very nice introduction to the paper, very easy. Just need to know all the different parts of the circle. For your exam, you should know that that one there is a segment. A segment. Looks a bit like an orange segment, doesn't it? Question 2. Circle the number that is in standard form. Okay, so a number in standard form needs to be the form a times 10 to the power of n, where this value of a has got to be a number which is greater than or equal to 1 and less than 10. And n has to be it has to be an integer, doesn't it? So a positive or negative whole number. Okay, so that's what a standard form looks like. So which ones are in that form? Okay, now this one, this first one, this is okay. 10 to the 4 part is fine, but this bit here, not so much. That isn't right, is it? It has to be greater than 1. Next one along. Yep, that bit's fine, and that bit's fine. Third one along, this bit is fine, but this bit is not so fine, is it? That's not a number between 1 and 10. Finally, that bit's fine. That's a number between 1 and 10, but that's not fine. That's not an integer, so that can't be in standard form. So only one that's got both bits in standard form correct, which is that one there, 6 times 10 to the 7. Question 3. Y is 1.5 times x. Circle the ratio that is equivalent to y to x. Okay, now these are getting more and more prevalent, these sorts of questions, where you're given either an equation or something you can turn into an equation, and then from that you're meant to derive the ratio between two unknowns. Okay, so let's rewrite what we've been given in words as an equation first. Y is 1.5 times x. So y equals 1.5. Well, 1/1.5 is 3 over 2, isn't it? 1 over 1 and 1/2. 3 over 2x. Okay, so we've got y is equal to 3 over 2x. That's our equation in y and x. And we need to turn this into a ratio. Now, the easiest way is to get it as a fraction of one value over the other. So if I take this x here and cross multiply it down here, we should get y over x equals 3 over 2. Once it's in this form, it's really easy to rewrite it in a ratio. We can take the ratio of this one over to this one is going to be this to this. In other words, the ratio of y to x is going to be 3 to 2, like that. So it's that one there. So, as I said, the easiest way I found to do these is just to try and rewrite whatever equation you've been given in the form like this of one unknown over the other, and then you can read these two numbers off here as your ratio. Okay. Question 4. Work out 40 as a percentage of 10. Circle your answer. Okay, so we want 40 as a percentage of 10. In other words, 40 over tenths is a fraction. So if I want to turn a fraction over 10 into a percentage, I need to change the denominator to 100, which I can do by multiplying by 10. But if I do that to the denominator, I have to do it to the numerator as well. So my 40 over 10 is the same as the fraction of 400 over 100. And any fraction over 100 is the same as that as a percentage, isn't it? So that is 400%. It's going to be that one there. Question 5. Match each sequence to its description. One has been done for you. You can see here we've got 1, 2, 3, 4, 5, 6 different sequences. And the first one is mapped as a Fibonacci sequence. It is, look, so 1 plus 1 is 2, 1 plus 2 is 3. And with a Fibonacci sequence, you get the next number in the sequence by adding together the last two. You can see that's the case all the way through there. What about the next sequence? I've got 1, 2, 4, 8, 16, 32. Now, from one term to the next, you can probably see that I'm multiplying through by 2. It's doubling each time, isn't it? It's times 2. So times 2 times 2 times 2. So anything that has a common ratio like that, multiplied through by the same number, that is a geometric progression. Next one, 1, 2, 3, 4, 5, 6. That one is going up in even jumps. It's plus 1 each time, plus 1, plus 1, plus 1. So any sequence that's going up in a fixed number each time, that's an arithmetic progression. Okay, what have we got now? 1, 3, 6, 10, 15, and 21. Now, if you drew those as a sequence of dots, I think you can probably see that this is the triangle numbers. It's that one there. 1, 4, 9, 16, 25, 36. I hope you can recognize is the square numbers, and that leaves me with the cube numbers 1, 8, 27, 64, 125, 216. Yep, that all looks good. Okay, all done. Question 6. The table shows information about the population of a city. And we can see the population in 2001 was 420,000, and the population in 2011, it's gone up. It's now 480,000. Okay, Liam claims from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011. He works out the population increase from 2001 to 2011 is 480 subtract 420, which is 60,000. So the population in 2021 should be 480 plus 60, which is 540. Does the population of 540 match his claim? You must show your working. Okay, so he has said here that from 2011 to 2021, the population of the city will increase by the same percentage as from 2001 to 2011, but he hasn't actually worked out what that percentage is. All he's done is subtracted one number from the other, so he's found the difference between those two numbers is 60, and he's added that same difference onto the population in 2011 to estimate what it will be in 2021. But that is not the same percentage. 60,000 as a percentage of the population in 2011, 60,000 over 420, is not the same percentage as 60,000 over 480. Okay, so we need to put that down somehow. So does the population of 540 match his claim? Okay, so first off, Let's see if we can work out the percentage increase, or the percentage change, I should say. Percentage change from 2001 to 2011. What's that equal to? Okay, well, if you use the triangle that I often use in these problems, final, original, multiplier. Percentage change, we want the percentage, which is kind of like the multiplier part. So we need to use final is equal to, multiplier is equal to final over original. So let's write that down as a formula. Multiplier is equal to final over original. Okay, so the final amount was 480. That's the amount in 2011, 480,000. And in 2001, the original was 420,000. So tapping that into a calculator, 480,000 divide by 420,000. That's 8 over 7. That's not very helpful. That's 1.1428. So I'm going to write that. I'm just going to round it off to. Just going to round that off to 1.143. Okay, so that is as a multiplier. So it's a percentage. That is 114.3%. So that means the percentage increase is 14.3%. Okay, now let's work out the percentage change from the next amount if it was going up in 60,000 again. So kind of run out of space here. So the percentage change from 2011 to 2021, again, our multiplier is going to be equal to our final over our original, which is equal to, well, what did he say it was? 540,000 divided by what it was in 2011, which was 480,000. Okay, and then dividing one of those by the other in my calculator. So I'm just going to type in 540 divided by 480 because that's going to give me the same number. I'm getting 1.125 now. So that's 1.125 as a multiplier, which is 112.5%. Okay, so that is an increase. I should have written increase over there. 14.3 increase there, and here it is a 12.5% increase. So they are different percentage increases. So what's the answer? Does the population of 540 match his claim? No. And we've got 14.3% and 12.5%. So our two percentages. Okay. There seems to be enough space there to do all the method, or maybe I'm just not using it well. Okay, let's move on. Question 7. On 3 days, Ali throws darts at a target. Here are his results. So we can see he was throwing them on Monday, Tuesday, Wednesday. He threw 20 on Monday, 30 on Tuesday, and 40 on Wednesday. And there is numbers of hits and misses. So we need to work out two different estimates for the probability of Ali hitting the target. Two different estimates. Now, I think this is a bit of a bonkers questions, really. I think generally with relative frequency, you'd probably want to take the combined results and use that one with the most number of results. I think any other calculation you do is going to be not as good, but anyway, let's work it out. So let's try using Monday's results. Then our probability of a hit is going to be successful outcomes, which is 15 out of total outcomes, which is 20. So 15 out of 20. Okay. Or we could use Tuesday's results, or we could use Wednesday's results, or we could use the total, or we could use the total of 2 results. Seems a bit weird, this question. I'm just going to use using totals. And the probability of a hit is going to be successful outcomes, which is 54 hits out of total outcomes, which is 90 throws altogether. So my 2 are going to be 15 over 20 and 54 over 90. Although I can't say I approve much of this question. Right, let's move on. 7b. Which of your 2 answers is the better estimate for the probability of Ali hitting the target? Give a reason for your answer. Okay, well, I think using the total results, as I say earlier, would be the best because it's got the most amount of results. And you will find over time relative frequency homes in more and more onto probability, or in other words, experimental probability gets more accurate with when you increase the number of trials. So I'm going to say that 54 over 90 is the better estimate, and the reason will be, I'm going to say that experimental probability, which is what we're doing here, isn't it? Experimental probability improves when increasing the number of trials. Okay. Question 8. Theo starts with savings of £18 and James starts with no savings. Each week from now, Theo will save £4.50 and James will save £4. Okay. In how many weeks will Theo and James have savings in the ratio of 15 to 8? Ooh, that's not very nice. Theo starts with savings of £18. Okay. Now, I suppose you could think of this as 2 linear equations, couldn't you? So Theo starts with savings of £18, and then so he starts with 18 and he saves £4.50. So if we did it like a graph, a y and x graph, then x could be the number of weeks and y can be the total savings. So Theo would start on 18 and then every week he would save £4.50, so it'd increase by £4.50 and so on, and another £4.50, and it would give you a straight line graph, wouldn't it, like that, with the equation y is equal to 4.5x, because he's saving £4.50 every week, plus 18, which is your y-intercept, isn't it? So that's y equals 4.5x. Oops, I should have written it where you could see it. Y equals 4.5x plus 18. So that's Theo's. Now James starts with no savings and he saves £4 each go. So he's going to start on 0 then, isn't he? And then he's going up by 4 each time. So kind of 1 along 4 up. So slightly less steep than the graph we've just drawn, and isn't it? It's going to have a slightly less steep gradient. So these graphs are going to be diverging over time, aren't they? Theo is going to start ahead and he's going to get more ahead over time. And the equation of that line then is going to be y is equal to 4x plus nothing. Okay, so then my 2 graphs then, and then so in how many weeks will in how many weeks will Theo and James have savings in the ratio of 15 to 8? So we've got to find a time where if we took a slice down here and we compared that point and that point, then one would be 15/8 of the other, which is not so nice. So like I say, clearly Theo is earning more and will continue to earn more, and the gap between them is going to get wider and wider. So it's going to be him who has the 15 and James who has the 8, isn't it, at that point? Okay, or you know, the equivalent ratio. So in other words, this value up here is going to be 15/8 of that one, isn't it? Okay, so if I take that equation then, 4.5x plus 18, I suppose what I'm saying is I want to find the value of x when that is equal to 15/8 of 4x. Okay, so what I'm saying is that's my yellow equation, isn't it? 4.5x, and this is my green one down here. So my yellow equation is 15/8 of my green equation. So then I've got an equation in x that I should be able to now go on and solve. Shall we try and do that then? So 4.5x plus 18 equals 15 lots of 4x over 8. Okay, let's just multiply out the bracket on the right. So 15 fours is 60x over 8 equals 4.5x plus 18. I'm tempted to cross multiply that 8 to get rid of it. So let's take that 8 and kind of move it over here. So that's going to give me 8 lots of 4.5x plus 18, and that's equal to 60x. Right, so multiplying out the brackets, 8 times 4.5 is 8 times 4.5. Could do it in my head, but I've got a calculator. So that's 36x plus 8 times 18. What's that? 8 times 18. That's 144. So I've got 36x plus 144 equals 60x. So let's subtract 36x from both sides. So that will leave me with 144 on this side and 60. Subtract 36, 24x over here. And then divide both sides by 24. I'm going to get 144 over 24. And that's going to be equal to my x. What's that on the calculator? 144 divided by 24. That equals 6. So x equals 6. So we're saying after 6, is it weeks? Yeah, 6 weeks. Then Theo is going to have 15/8 of James's wages. That was truly horrid. Okay, but we got there. Good job. Question 9. The length of each side of a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. Okay, so I always draw a kind of a scale when I'm doing these sorts of error interval questions, and I mark on the number they give me, and then I imagine the scale either side of it. So if this was going up in 1 decimal places, then the next decimal place up from 8.4 is going to be at 8.5, and the one below it is going to be 8.3. So then the numbers that round to 8.4 are the ones that are going to be halfway between those two, aren't they? So halfway between 8.3 and 8.4 are going to round up to 8.4, and halfway between 8.4 and 8.5 are going to round down. Now, I know you're going to tell me that 8.45 rounds up, but it still becomes the boundary where you make the decision about where you want to round up one way or the other. So halfway between 8.4 and 8.5 is 8.45, and the other boundary is going to be halfway between 8.3 and 8.4, which is 8.35. Okay, so they form my two intervals. 8.35 and 8.45. You can see that this one is less than or equal to, and this one's strictly less than, which is why I can use that right hand limit. Okay, 9B, complete the error interval for the perimeter. Okay, so this is a regular pentagon. What does a pentagon look like? It is a 5-sided polygon. 1, 2, 3, 4, 5. Okay, so each one of those is going to be between, any one of those sides is going to be between 8.35 and 8.45. Okay, and what we're going to do is multiply those by 5. So what I need to do then is take the lower limit, 8.35, and times that by 5. 8.35 times 5. That gives me 41.75. So that's going to be the lower limit. And then taking the upper limit, 8.45, and timesing that by 5, it's going to give me the upper limit, 42.25. Okay. Question 10. Now we're told that the volume of a sphere is 4/3 pi r cubed, where r is the radius, and we've been given this diagram, which is a hemisphere, isn't it? A container is a hemisphere of radius 30 centimeters. So I'm just going to draw that on then. So here's the center of my sphere, and then the distance from the center to the edge in any given direction is going to be 30 centimeters. Okay. Right, so sand fills the container at the rate of 4,000 cubic centimeters per minute. So I'm putting sand in at 4,000 centimeters cubed per minute. Okay, so I suppose it's slowly filling up then, isn't it? So you're going to get sand kind of appearing in the bottom here, slowly filling up. Right, so does it take less than 1/4 of an hour to fill the container? You must show your working. Okay, so I suppose what we need to do then is to find the total capacity of that hemisphere. How much sand will it hold all together? And then we're going to have to compare that with the rate it's filling up at 4,000 cubic centimeters per minute, so we can work out then how long it would take to fill, and we can see then if that is more or less than 15 minutes. Okay, so let's do that. Let's work out the volume of the hemisphere then. So the volume of the hemisphere is going to be half of the volume of a sphere, which is, we were told, was 4/3 pi r cubed. Okay, what's a half times 4/3? That is just 4/6, isn't it? 1 times 4, 2 times 3, it's 4/6. 4/6 of pi times r. What were we told? R was 30, wasn't it? So that's going to be 30 cubed. Okay. So I suppose I need to work it out with the pi, don't I? So I'm going to have to type that into my calculator. I'm going to type 4/6 times 30 cubed times pi. Well, thank you, calculator. That's 18,000 pi, which is 56,548. I'm just going to write it down with pi in it in case I need to do some further calculation. And then I'll write it down as a decimal rounded off. So that's 56,548. I'm just going to round it off to 56,550, I think. 56,550. 4 significant figures at the moment, and I can drop down to 3 later perhaps. Okay, so that is the number of cubic centimeters that are inside that hemisphere. Okay, now we're told that it fills at the rate of 4,000 cubic centimeters per minute. So if I divide that number by 4,000, it should tell me the number of minutes it takes to fill. So time taken is going to be volume then divided by 4,000. Now I've written down the rounded off amount, but I'm just going to use the one that's still in my calculator. I'm going to divide that by 4,000 to retain accuracy. And I'm told now that is 14.137, which I'm going to round off to three significant figures, which is 14.1. So that is in what, minutes? Okay, so if we answered the question, what was the question? Does it take less than a quarter of an hour to fill the container? That was the question. So did it? Well, it took 14.1 minutes. Is 14.1 less than a quarter of an hour? Yes, it is. So the answer is yes. Question 11. 2 ordinary fair dice are rolled. So fair means that they're going to have their theoretical probability values. Complete the tree diagram. First dice, second dice, 1/3 less than 3, and what is more then? So 1/3 and 2/3 then, isn't it? So each kind of branch of your probability tree should add up to 1. So I've got 1/3 in one direction, I must have 2/3 in the other. Okay, and again over here 1/3 and 2/3, 1/3 and 2/3. That was easy. Okay, so then work out the probability that both dice land on a number less than 3. So both dice land on a number less than 3 is this route, less than 3 here, and then less than 3 here. Okay, so I've got to go up that branch. That's the only way I can go, isn't it? That both land on a number less than 3. So the probability that both less than 3 is going to be those numbers along the route multiplied together. So that one multiplied by that one, isn't it? So 1/3 times 1/3, which is 1/9. That's a super easy probability question. Okay, part C says work out the probability that exactly one of the dice lands on a number less than 3. Exactly one. What does exactly one mean? That means that either one was, let's just get rid of the yellow, one was less than 3 and the other one was 3 or more, or we could have had that this one was less with 3 or more, which means that one must be less than 3. So either of those two routes. So it's going to be those two routes added together then, isn't it? So then the probability exactly one of the dice lands on a number less than 3. I think it's good practice to just describe your probabilities properly. So probability of exactly 1 less than 3 is going to be that less than 3 over 3 route, so the green route, less than 3 over 3, which is 1/3 times 2/3. So it's going to be 1/3 times 2/3, or, which in probability means add, or the other way, which was 2/3 times 1/3, which you'll notice is exactly the same thing. 2/3 times 1/3 is 2/9, so you're going to get 2/9 plus 2/9, and 2/9 plus 2/9 is 4/9. Okay. Question 12. A straight line is drawn on the centimetre grid. Now Faye assumes that the scale is 1 centimetre represents 1 unit, and then use her assumption to work out the gradient of the line. Okay, so when I work out gradient, it's a good idea to pick 2 points that are very easily to read, that lie on your grid. I'm going to take those 2 endpoints, they're both easy to read, and then I'm going to do the change in y, which is that distance, 1, 2, 3, 4 units in that direction, divided by the change in x, which is 1, 2, 3, 4, 5, 6, 7, 8 units. So then the gradient, M for gradient, don't ask me why, change in y, 4, divided by change in x, 8, which I suppose it's the same thing as a half, isn't it? Okay, so gradient is a half. Okay, that's assuming that it was 1 centimeter, 1 unit. In fact, the scale is 1 centimeter represents 2 units. Which statement is correct? The answer to part A is too big, the answer stays the same, or the answer is too small. Now, if I'm changing both of these by a factor of 2, so this was 2 times bigger and this time is 2 times bigger, I'd have 8 over 16, and 8 over 16 is still the same thing as a half. So because I'm changing both by a factor of 2, it's a bit like a enlargement. You're not really changing the gradient, are you? It's going to stay the same. So my answer is going to be, it stays the same. Question 13. Show that for x not equal to minus 1, that 8x squared minus 8 simplifies to the form ax plus b, where a and b is integers. Now, don't worry too much about this bit up here. All that bit there is saying is that the denominator of this fraction, this bit down here, can't be 0. If x was minus 1, then 4 lots of x would be minus 4, and minus 4 plus 4 would be 0. And then you would have division by 0, which, if you've ever typed that into your calculator, you will know is a headache for mathematicians. So that is just to avoid that expression having a denominator of 0. So they have to put those things down. So 8x squared minus 8 over 4x plus 4. We want to show that that simplifies to ax plus b. Let's have a look at the top line there. I've got 8x squared minus 8. So I've got 8 and 8. So I reckon I can factorize those out. That might make life a lot easier. So the top line is going to become 8 lots of x squared minus 1 then, isn't it? If I remove 8 as a common factor. On the bottom I've got 4x and I've got 4, so again I can take 4 as a common factor out of those two, which will leave me with x plus 1 underneath. Okay, so I can see straight away that I can then cancel that 4 into the 8 and leave myself with 2. That will make things a little bit easier. But also on the top I've got x squared minus 1, which you'll notice is a quadratic expression. It hasn't got a term in x though, and there's a minus 1, so you should already be thinking what that is. It's what we call in maths the difference of two squares, and anything of the form a squared minus b squared factorizes into the form a plus b, a minus b. Okay, so that's a very handy identity to know and remember. So factorizing, use the difference of two squares to factorize x squared minus 1. That is the same thing as x plus 1, x minus 1. If you don't believe me, multiply it out and check. And then that's over x plus 1, isn't it? So you notice now that I've got 3 factors on the top, 2x plus 1 and x minus 1, and 1 factor on the bottom, x plus 1. So I can cancel that into that, and it will just leave me with the 2 and the x minus 1 left. Okay, so is that in the form ax plus b? Almost, if I multiply it back out again. So 2x minus 2, now that is in the form of ax plus b, where a is 2 and b is minus 2. Okay, all done. Question 14. The scale drawing represents a garden. Water from sprinkler at P reaches up to 20 meters from P, and water from the sprinkler at Q reaches up to 25 meters from Q. We're given a scale, so using a pair of compasses, show the region that water from both sprinklers reaches. So what you need to do is draw circles then based on P and Q that reach that far then, don't we? So using the scale, 1 centimeter represents 5 meters, then 20 meters up here, look, that's going to be 4 centimeters on our scale. So we need to draw a circle of size 4 centimeters centered on P. So sticking the pointy end of the compass in P, and and setting your compass so the distance between the point and the tip is 4 centimeters. You can even use the grid on the paper to match them up. So, you know, if you stick one end of the compass in P and the other one 4 units away from P as your starting point, and then draw a circle, you should be okay. I'm not going to bother doing this on an actual one. I think you can work it out from what I'm doing here. So drawing a circle. Okay, my computer's being a bit of a pain, so here's one I've created earlier. So you can see that the radius of this circle I've drawn is 4 squares, which represents 20 meters on my scale, doesn't it? So Q then, I'm going to do the same thing, just going to get my computer now to draw one of radius of 5 squares on my computer. So here's another one I prepared earlier, and you can see that this one has a radius of 5 squares representing 25. Okay, so stick the pointy end in the one, set them to the right size, draw the circles, and show the region that water from both sprinklers reach then is going to be the intersect of those two. So I'm just going to shade that bit in there. Okay. And just to make it clear, right, both there on my diagram, super clear. Question 15. 100 men and 100 women took a test, and here are their scores. So we can see men had a median of 28, an interquartile range of 7.5, and a range of 31, and women had a median of 30, an interquartile range of 9, and a range of 37. Using this data, which statement must be true? Tick one box. Is it true that men had a higher average score than women? Well, no. That one isn't right, is it? Okay. Men had a median score of 28 and women had a higher score of 30. So that one is definitely out. Right, what's next? Men had more consistent scores than women. Now, consistency is a measure, or as a kind of a quality of dispersion, how widely dispersed your data is, or what the range is. So interquartile range and range are both measures of dispersion. Okay, we would say that interquartile range is probably a better measure than range. Range is madly affected by your highest and lowest points, which can often be outliers. So interquartile range ignores the top half and top quarter and bottom quarter of your data, so it's often a much more reliable measure of dispersion. But anyway, just need to compare the two. So you can see here that men had an interquartile range of 7.5, which means it's less spread out than the women's score of 9, and they also had a smaller range than women, which was 31 to 37. So I would agree that men had more consistent scores than women. There was less variation between the men's scores compared to the women's scores. So less variation means more consistency. So I'm going to say that one is true. Let's just double check the last two. Women had the higher score. Well, there is no way of telling that from the data. You can't see which is the highest score. You can see that the range is widest for women, but that isn't going to tell you definitely that it's going to be the higher one. They could have the lowest score, and then 37 above the lowest score would still not be the highest score. So we can't tell from that one. It's unclear if that is true or not. A man had the lowest score, and that's the similar argument here. We can't tell from this data who had the highest and who had the lowest. It's not possible to tell. So that is unclear as well from this data. There's only one that I can hand on heart say must be the case, and that is that one there. Men had more consistent scores than women. Question 16. Some concrete has volume 3.8 cubic meters. The density of concrete is 2,400 kilograms per cubic meter. Work out the mass of the concrete. Okay, well, there is a handy formula involving density, mass, and volume. Do you know what it is? Density is equal to mass over volume. That's one that you might find handy for science as well. So we have here, we've been given the density and we've been given the volume. What we want to know is the mass. So we really want to rearrange this equation so it's in the form of mass. So kind of cross multiplying this volume up here, I can then say that mass is going to be equal to density times volume. Density we said was 3.8. Let's just check the units match. That's in cubic meters and the other one is kilograms per cubic meter. They seem to be matching up. So I can multiply them together and it will give me my answer in kilograms then, won't it? Okay, reaching for a calculator. 3.8 times 2,400 gives me 9,120 kilograms. 9,120 kg. Okay, part B. The 3.8 cubic meters of concrete is made into the shape of a cylinder. The base has a radius of 0.5 meters. Work out the height of the cylinder. Okay, so what do we know? We know the mass of this is 9. So we know the volume, don't we? The volume. Might as well just use the volume. So 3.8 meters cubed. So that's the volume. So that's the volume. We know the radius. So what we want to know is h, the height. Now luckily I know a formula for cylinders. A cylinder is just a circular prism, isn't it? Okay, and the area of the volume of a prism is the cross-sectional area, which in this case is a circle, pi r squared, times its height. So using the fact that volume is equal to cross-sectional area, pi r squared, times the height, I've got all the bits that I need here then, isn't it? I'm going to rearrange for h. So taking this bit and moving it down there, look, I can say that h then is equal to the volume divided by pi r squared. Okay, what's that equal to? The volume we said was a 3.8 cubic meters, and we need to divide that by pi times r squared, 0.5 squared. Time to reach for the calculator again. So 3.8 divided by 0.5 squared divided by pi is 4.838, which I'm going to round off to 4.84. 4.84 meters. Question 17. A ball is thrown vertically upwards. The graph shows the height of a ball above the ground after it is thrown. Okay, and then we've got a graph and it's a lovely parabola. It always amuses me when students say, "Oh, sir, why do we have to learn about quadratics?" And all you have to do really is throw a ball and you'll know. It's quite a very common thing when you've got gravity, that when you throw something it's going to fall and form some sort of parabola. So for how many seconds is the ball at a height of more than 2 meters? Okay, so 2 meters. Let's get the ruler out. Okay, ruler. So 2 meters is this line here, isn't it? Let's just mark that on the diagram. So that's my line, 2 meters. So we can see that the ball is above the 2 meter mark between this time here 0 and this time here 3. Okay, so it's 3 seconds then, isn't it? So how many seconds is the ball at a height of more than 2 meters? It's going to be 3 seconds. Part B. After how many seconds is the ball at instantaneous rest when it is in the air? Okay, now the point at instantaneous rest is this point here, the maximum point on the graph. For this part of the graph, you can see its height is, so let me just get that. So for this part of the graph, you can see the height is increasing, and for this part of the graph you can see that the height is decreasing. So there is a split second where the ball is neither increasing nor decreasing, and that is that maximum point on the graph there. Can't remember what the question was now. So after how many seconds is the ball at instantaneous rest? It's that point there. It's basically where is the maximum, and the maximum is at the point 1.5, isn't it? X equals 1. Or t is equal to 1.5. Okay, so after how many seconds? It's going to be 1.5 seconds. C. Work out the average speed of the ball when it is moving downwards. Okay, so coming back to the graph, it is moving downwards for this green section, isn't it? Okay, so it starts here and it goes down to 0, doesn't it? So it goes this distance, which is what, 4.5 down to 0. So it travels 4.5 meters then, doesn't it? It falls 4.5 meters. How long does it take? So this part of the graph, this green bit, starts, we said, at 1.5 and ends when it hits the ground there at 3.5. So 1.5 to 3.5 is 2 seconds then, isn't it? That's 2 seconds. So it takes itself 2 seconds to fall 4.5 meters. Okay, so time is 2 seconds. Distance is 4.5 meters, and using the DST triangle, distance, speed, time, cover up the thing we want to find. Speed, average speed is distance divided by time, isn't it? So speed equals distance over time. So it travels a distance of 4.5 meters over a time of 2 seconds. So it's 4.5 divided by 2. So that's 2.25 meters per second then. Question 18. The solution of 3 to the power of x is 300, and that lies between two consecutive integers. Work out the two integers. Okay, so we need to know 3 to the power of what is equal to 300. And we want to find the numbers either side of that. So let's just, I know that 3 to the power of 3 is 27, so it's going to be more than that. 3 to the 4 is 81. What's 3 to the power of 5? 3 to the 5 is 243. So we're close already then. I think that's going to be one of them, isn't it? And then 3 to the 6 is what? 3 to the power of 6 is 729. So I found them already. So work out the two integer powers of x, where x is 5, 3 to the power 5, or x is 6, 3 to the power 6. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, sheres, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Question 19. A pentagon is made from a square and an isosceles triangle. Work out the perimeter of the pentagon. Okay, so this is a square and an isosceles triangle. So let's just divide it up then. Ruler, where are you? Here we are. Okay, let's just divide that up as told. So that is my isosceles triangle sitting on top of my square. Now, clearly this angle here is a right angle, and I'm assuming then if this is an isosceles triangle, then this angle must be equal to this one. So if I take 90 off of 125, I can see that this angle here must be 35, 35. What's that make the top then? 35 and 35. 70, take a base from 180 is 110. Okay, now we want the perimeter which is the distance around the shape. Now if I start here and walk around the shape, then I'm going to be going 12, 12, and 12, so 3 lots of 12s, and then I'm going to go down around these 2 sides, equal sides of my isosceles triangle. Okay, so I know the sides of the square are 12, so that's 36, 3 12s are 36, but at the moment I don't know yet what the lengths of those sides of the isosceles triangle are. Now I know that this long side of the isosceles triangle must be 12 because it matches the side of the square. So how can I find then the shorter side? Well, if you think about it, we know this angle here is 110, or we've just found it, and we know that this side down here is 12. We know this angle here, so then we want to find this side here, don't we? So I've got 2 pairs of sides and angles, matching sides and angles that go together. So this looks to me like a job for the sine rule. So like I say, the sine rule is about matching pairs. So you want to be on the lookout for matching pairs of sides and angles if you want to use the sine rule. Sine rule is a over sine A equals b over sine B equals c over sine C, or the other way around. So sine A over A equals sine B over B equals sine C over C. We only ever use 2 of the 3 parts, and we should pick the version of it with the thing that we want to find on the top. So here I have got a side that I want to find, so I'm going to use it with the form with the sides on the top. So a over sine A equals b over sine B. That form is the one we're looking for. So what pairs do we know about then? So my A then is going to be my unknown side. Let's call that one there then the A. So then this would be side A then, wouldn't it? And this would be, or angle A, sorry, and this would be angle B, and this is side B. Okay, so I've got A, this is the one I want to find, over sine 35. And that's equal to B, which is my other length that I do know, which is 12, divided by the sine of 110. Okay, so then rearranging that. So A then is going to be 12 sine 35 over sine 110. Pick up the calculator, tap that in, 12 sine 35, close bracket, divide by sine 110. So that's giving me 7.32 to 3 significant figures. Just going to write that down. 7.32. Now remember I need 2 of those, don't I? Because I've got my 2 equal sides of the isosceles triangle that I'm going to walk around. So then my perimeter is going to be my 3 lots of 12 plus my 2 lots of 7.32. Okay, so if I take my last calculated answer and I double it by timesing it by 2, and then I add on my 36, I should get the total. So that comes to 50.6 to 3 significant figures. 50.6 centimeters. Question 20. Here is an inflated swimming ring with dimensions in centimeters. We're told that the volume of the ring is V cubic centimeters, and it's given by this formula: V equals 0.25 pi squared B minus A squared B plus A. Now, the mathematical name for this shape, it's kind of like a donut, isn't it? So the mathematical name for a donut is called a torus. That's its proper name. And we've been given down here the equation for finding the volume of a torus. Now, this is probably the first time you've seen this formula. Before you go and shout and scream at your maths teacher, it's not on the syllabus. You're just expected to be able to use it. You should be able to use any given formula because you know how to substitute into a formula and use them. Okay, so torus is probably new to you, but don't beat up your maths teacher about it. It's just one of those things you're expected to know how to use a given formula in your exam. Okay, so we've been given values of A and B. Here they are. Look, work out the volume when A is 20 and B is 30. So basically all we've got to do is substitute our values of A in here, look, and our values of B in here, and then shove it into the calculator and work it out. So it's not actually a big deal. So let's go ahead and do that then. So V is equal to 0.25. I'm just going to rewrite that as a quarter. So it's going to be pi squared over 4 basically. I think that's easier to type in. So then B is 30 and A is 20. So 30 minus 20 squared times B, again, which is 30, plus 20. Right, what's that? Let's see if we can simplify that down a little bit. So pi squared, 30 minus 20 is 10. 10 squared is 100. So that's 100 times, still pi squared over 4. And then the second bracket, 30 plus 20 is 50 then, isn't it? So 100 times 50. So in other words, we've got 5,000 pi squared over 4. I'm just trying to put as much together as I can before I pick up the calculator. So what I have to type into the calculator is easier. Okay, so here we go. So 5,000 times pi squared, all divided by 4. So that is 12,337. I'm going to round it off to 3 significant figures. So that's 1,234 is just 12300 then, isn't it, to 3 significant figures. Question 21. Liz and Tia are walking towards a shop along different straight paths. The diagram shows their position at 2 p.m. Okay, so here's Liz over here and here's Tia, and they're both walking from different places to the same place, to this shop over here. Okay, now it says, assume they walk at the same speed, who will arrive at the shop first? Okay, right, well, we know Liz is going this direction and we know that is 80 meters. So if that distance is shorter than the distance that Tia is walking, then Liz is going to arrive first, isn't she? But if the distance from Tia to the shop is shorter, then Tia is going to arrive first if they're walking at the same speed. Now at the moment we don't know what that side is there, do we? So that is what we really need to find. Okay, so we've been given two sides of a non-right angle triangle, and we want the third, and we know an angle, which is a job for the cosine rule. Okay, so if you remember the form of the cosine rule, so a squared starts off a little bit like the Pythagoras theorem. A squared equals b squared plus c squared minus 2, these two letters again, 2bc cos, and capital this one, cos a, that's how I remember it. So a squared equals b squared plus c squared minus 2bc cos a. Okay, and that's for a triangle where the corners a, b and c match the opposite sides, so a, b, c, like that. Okay, so this is my a and this is my angle a. So a squared is what I'm trying to find, and so I know it's cos 75 at the end. And then my b squared and c squared are going to be my two other sides then, aren't they? They're going to be the 60 squared plus the 80 squared minus 260 80 cos 75 then. Okay, so can I simplify this at all before I reach for the calculator? I probably could, but 60 squared, what's that, 36 with 2 zeros? I think I might just do it on the calculator. So 60 squared, I might break it down though. So 3600 plus 80 squared. 80 squared is 6400 minus 2 times 6 times 80. 2 times 60 times 80. That's 9,600. Cos 75. I could just put it all in one go, but So let's type it in. 3600 plus 6400 minus 9600 cos 75. So that comes out to be 7515. Remember, that's the square of the answer though, isn't it? So we need to square root that to find A. So then A is going to be the square root of that. So just finding the square root of my stored answer, so don't lose accuracy, root answer. That comes out to be 86.7 to 3 significant figures. Okay, what was it? It was meters, wasn't it? Now, if you remember rightly, Liz was 80 meters away. So if Tia is 86.7 meters away, and they're walking at the same speed, then clearly Liz is going to get there first. So who will arrive at the shop first? The answer is Liz will. Okay, now part B says, in fact, Liz walks at a faster pace than Tia. How does this affect the answer? Well, if you remember, Liz is arriving first anyway, so if she walks faster, it's not going to change the answer, is it? She's still going to arrive first. She's just going to get there even quicker than she did before. So I'm going to write down Liz still arrives first. No change then, is there? Doesn't affect the answer. The answer to part A was Liz arrived first, and the answer is still that Liz arrives first, so there is no change to the answer. Question 22. A circle centre O passes through 5, 0. What is the equation of the circle? Okay, so we've got the equation of the circle centred on the origin. Now you should know that the equation of a circle centred origin is the form x squared plus y squared equals r squared, where r is the radius. Okay, so the radius of this circle is that distance there, which must be 5, because that coordinate is 5, 0. So the equation of this circle is going to be x squared plus y squared equals 5 squared, which is 25, that one there. Question 23. Solids x and y are similar. X has a volume of 64 cubic centimeters, y has a volume of 343 cubic centimeters. The surface area of x is 176. Work out the surface area of y. Okay, so we've got two shapes, two lumps of undescribed size, of undescribed shape, sorry. And we know that one is similar and bigger than the other. So what's the scale factor? We need to find the scale factor, don't we? Now, there is a relationship between the scale factors of lengths, areas, and volumes. So basically, let's say the scale factor here is n. Then the scale factor of lengths is n. So the scale factor of areas is going to be the square of that. It's going to be n squared, and the volumes then are going to be in the relationship of n cubed. Okay, so we've got the two volumes. We know that this one is 343 cubic centimeters, and we know that this one is 64 cubic centimeters. So if we divide one by the other, we shall find the scale factor of their volumes, which is a cube of the scale factor of their length. So we should then be able to use it to work out the scale factor of their areas. Okay, so n cubed then, the scale factor of their volumes, is going to be my big shape, 343, divided by my equal shape, 64. So then, I've just noticed they're cube numbers. So I can then work out n very easily then by cube rooting those two numbers. So what's the cube root then of 343 over 64? Well, cube root of 343, I do recognise it, do you? Personally, I think it's a good idea to learn by heart your first 10 cube numbers and square numbers. And then so when you're in an exam, it's very easy for you to do these sort of things. So cube root of 343 I already know is 7 because I know my cubes. And the cube root of 64 I also know is 4. So then the scale factor of their lengths is 7 over 4. So n squared is the scale factor of their areas, or even including surface area. Any two-dimensional area that is the same on both objects will be in this same ratio. So squaring 7 and 4, I'm going to get 49 over 16. So then that is the scale factor from the small surface area to the large surface area. Now we were given the small surface area. It was 176. So what we need to do then, surface area of y, surface area of y is going to be the surface area of x, which is 176, times by our area scale factor, which is 49 over 16. Okay, so grabbing the calculator, 176 times by 49 divide by 16. That comes out to be 539. Okay, so that's my answer, 539. Question 24. A tank is a cuboid measuring 50 centimeters by 35 centimeters by 20 centimeters. All lengths are in the nearest centimeter, and that has been given in bold, which is normally shouting at the student. This is important. Take note. Okay. The reason it's there is to signal that this is a limits of accuracy question. Unusual, seeing we've already had one so far in the paper. This is the second one, isn't it? Very odd that we should have it twice. But anyway, can imagine a scale with 50 written on it. 1 centimeter above is 51, 1 centimeter below is 49, same as I did earlier. So all the numbers which are halfway between those, or closer to 50, round to 50. So our 50 is actually going to be anywhere in there, isn't it? Okay, so which could be as low as 49.5. It could be as much as 50.5. Okay, and similarly, the 35, we do the same thing there. 35, 36, 34, halfway between. It's going to round to 35, so that is 34.5 is the lower limit, and 35.5 is the upper limit. All those numbers round to 35. And finally, 20 centimeters, 20 in the middle, 21 and 19. The numbers that round to 20 are going to be the ones halfway between those, which is 19.5 to 20.5. Right, so we're comparing it to this other container, which is exactly 34 liters. So basically, we want to find the upper and lower bound of this cuboid and compare it to this exact capacity of 34 liters and see what we've got. Okay, so the smallest possible cuboid is going to be my 3 small measurements. Okay, so lower bound volume is going to be 49.5 times 34.5 times 19.5, which is what? 49.5 times 34.5 times 19.5. That comes out to 33301. 33301. Okay, now the upper bound, I'm going to get, for the volume, it's going to be those 3 at the other end, aren't they? Multiplying those together. So that is going to be 50.5 times 35.5 times 20.5. Again, tapping that into the calculator. 50.5 times 35.5 times 20.5. That comes out to be 36751. 36751. Now these are going to be in cubic centimeters, aren't they? Because I use centimeters. And I know that 1 litre is 1,000 cubic centimeters. If I divide these by 1,000, it will give me the capacity in litres. So this one is roughly 33.3 litres, and this one is 36.7 litres. So our volume then is going to lie between those then, isn't it? It's going to be anywhere up to that or down to that one. Okay, so comparing then with our 34 litres, we can see our lower bound is smaller than 34 litres and our upper bound is larger than 34 litres. So we can't tell, can we? It could be either side. So I'm going to tick that can't tell box. Okay, because it could be one or the other. Question 25. The Venn diagram shows some information about 150 students. So that little squiggly E stands for the universal set. That's the set of everything involved in this question, and it contains 150 students. C is the students who study chemistry, and P are the students who study physics. So you can see that we know how many students study physics only and chemistry only. We don't know yet how many study both or how many study none. So I suppose the question is going to be around that then, isn't it? So the probability that a physics student chosen at random also studies chemistry is 5/12. One of the 150 students is chosen at random. Work out the probability that the student does not study either chemistry or physics. Okay, so my thinking is that this 5/12 here we're going to use to find x, and once we know x we can work out y. Okay, that's the plan anyway. So the probability that a physics student chosen at random also studies chemistry is 5/12. Okay, well, probability is successful outcomes over total outcomes, isn't it? So probability is successful outcomes over total outcomes. Now we know that the probability is 5/12. What else do we know? Do we know the successful outcomes? Successful outcomes in this case, probability that a physics student chosen at random also studies chemistry. That's the number in the intercept, isn't it? So that is our x. X is our successful outcomes. And then the total outcomes is everyone in the physics set, which is our x and our 35 combined. So then that's going to be x plus 35 down there. Okay, so we know that x divided by x plus 35 is equal to 5/12. Okay, I'm going to cross multiply this. So I'm going to move that up there, and I'm going to take the 12 and I'm going to move it up there. So that gives me 5 lots of x plus 35 is equal to 12x. Multiplying out the brackets, 5x plus 5 lots of 35. What's that? 70, 140, 175. Plus is equal to 12x. Okay, taking 5x off both sides, 175 then is equal to 7x. And 175 divided by 7 then. 175 divided by 7, 25. So that tells me x is 25. Okay, so I've got 25 students in here then. So now I can, well, I know that altogether there's 150, and I know everything apart from y now, don't I? So I know that my 47 plus my 25 in the middle plus my 35 plus y is everything, and that is 150 students. Okay, so adding these together, what's that? 47, 25 and 35. Well, 25 and 35 is 60, add 47 is 107. So then y then is 150 subtract 107, and 150 subtract 107 then is going to be 43. So y is 43. Y equals 43. Just checking I've answered the right question. Work out the probability that the student does not study either chemistry or physics. Okay, so that isn't the answer. I found y, but the probability then is successful outcomes over total outcomes. So the probability of neither, which is 43 over 150. 43 successful outcomes over a total of 150 outcomes. Question 26. A curve has equation y equals 4x squared plus 5x plus 3. A line has equation y is equal to x plus 2. Show that the curve and the line have exactly one point of intersection. Do not use a graphical method. Okay. Well, I am going to quickly use a graphical method just to illustrate the point. If you've got, well, the first one is clearly a quadratic curve, isn't it? So it's like a parabola. And the second graph is an equation of a straight line. So either your equation of your straight line is going to kind of skewer your parabola in two places, in which case you will have two solutions, 2 points of intersection, or your parabola and your line are just going to touch like that, in which case you have 1 point of intersection, or your parabola and your line totally miss each other like that, in which case there are no solutions. So we are assuming then, or wanting to show that it's this scenario there, that there's just one solution. But we're not allowed to do it graphically. We're going to have to do it algebraically. Okay, so we want to basically solve these simultaneously, which is very easy to do because this is in terms of y and this is in terms of y, so we can just substitute one inside the other. So this is equation 1, this is equation 2, and we're going to substitute equation 2 into equation 1. So we're going to start with equation 1, 4x squared plus 5x plus 3, and we're going to sub in for y is equal to x plus 2. So we're just going to connect them where the y's are. Okay, so 4x squared plus 5x plus 3 is equal to x plus 2. Okay, taking x away from both sides. So if I subtract x from here and subtract x from here, I'm going to get 4x squared plus 4x plus 3 is equal to 2, but I'm also going to subtract 2 from both sides. Okay, and that's going to leave me with 4x squared plus 4x plus 1 is equal to 0. Okay, collecting everything on one side, that is. So I've got 4x squared plus 4x plus 1 is equal to 0. I want to now factorize if possible. So I've got a 4x at the beginning, a 4x squared at the beginning, and I've got a 1 at the end. Okay, so that must be a 1 and a 1, because I can only multiply 1 with 1 to get 1. Now, I could have 4x and x in here, or I might have 2x and 2x. 2x times 2x is also 4x squared. I'm suspecting it's this one because I'm expecting there to be a repeated root. If I got 2x times 1, that gives me 2x, and 1 times 2x is going to give me 4x, so that is actually the solution, isn't it? It's 2x plus 1, 2x plus 1. In other words, you've got 2x plus 1 all squared is equal to 0. So when is 2x plus 1 equal to 0? It's equal to 0 when x equals minus a half. So we've got a repeated root here with one solution. X equals minus a half. So therefore, one solution only. Oops, can't spell only. Only x equals minus a half. Job done. Question 27. Prove algebraically that 2.75 reoccurring converts to the fraction 124 over 45. Okay, so what does 2.75 reoccurring look like? It's 2.755555 and so on. Okay, let's make that equal to x. Okay, Now, if x is 2.75555555, then 10x is going to be 27.55555, and 100x is going to be 275.55555. Yeah? These go on forever, don't they? So if I then take 100x and I subtract 10x, what I'm going to get is 275.55555 minus 27.55555, and so on. So what is that then? Well, 100x take away 10x is 90x, and 275.5555 minus 27.55555, you can see that these are going to cancel with those, so we don't have to worry about all the recurring 5s now. And 275 subtract 27 gives me, what's that, 250, 248 then, isn't it? 248. Okay, so then my value of x, just dividing both sides by 90, is going to be 248 divided by 90, which is a fraction. Can that fraction cancel down? I'm just going to type it in using the fraction key on my calculator and see if my calculator will find any. Oh yeah, there we go. Simplifies to 124 over 45, spookily. 124 over 45. Okay, so it works then, doesn't it? We've shown that it converts to 124 over 45. Question 28. F of x equals 5 minus x and g of x equals 3x plus 7. So we're asked to simplify f of 2x plus g of x minus 1. Okay, so basically when you've got something inside the bracket, that is the value that you're giving to x. So here, f of 2x is going to be 5 minus, going to sub in 2x for x. So that first part is going to be 5 minus 2x, and then plus g of x minus 1. Where I see x, I'm going to write x minus 1. So I'm going to write x minus 1 in there, just like I wrote 2x in there for the first one. So 3 lots of x, which in this case is x minus 1, plus 7. Okay, so simplifying that, I've got 5 minus 2x, multiplying out the brackets, plus 3x minus 3 plus 7. Collecting like terms, I've got minus 2x plus 3x, which is x. And I've got 5 plus 7, which is 12. Take away 3, which is 9. So x plus 9. So it simplifies to x plus 9. Question 28b says, solve g to the minus 1 of x is equal to 2x. Now, g to the minus 1x is the inverse function. Okay, now we learned earlier that g of x was 3x plus 7. So if g of x is 3x plus 7, and we want to work out what g to the minus 1 of x is. Now let's take that equation 3x plus 7, or that function, and put it equal to y. I'm going to rearrange it for x and then reform the inverse function from that. So 3x plus 7 is equal to y. Let's subtract 7 from both sides. You're going to get 3x is equal to y subtract 7. And then dividing both sides by 3, I'm going to get x is equal to y minus 7 over 3. Okay, so I've made x a subject. So from that, I can tell that the inverse function g to the minus 1 of x is going to be equal to, I'm just going to take this expression here, y minus 7 over 3, and I'm going to rewrite it, but with that one replaced back with an x. So I'm going to write x minus 7 over 3. Okay, so that's my inverse function g to the minus 1 of x. Right, now we're told in the question, or we're asked in the question, to solve g to the minus 1 of x is equal to 2y. So I'm going to take this expression I've just made for g to the minus 1 of x and equate it with 2x. So x minus 7 over 3 is equal to 2x. Okay, now we just need to solve for x. So multiplying both sides by 3, I'm going to get x minus 7 is equal to 6x. Subtracting x from both sides, I'm going to get minus 7 is equal to 5x. So then x is going to be minus 7 divided by 5 then, isn't it? So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.